Hello guys, my name is Engineer Holiday. We want to talk about a simple microscope, and I want to look at a detailed explanation about a simple microscope. What is a simple microscope? A simple microscope is a magnifying glass, or what we call the hand glass, used to see a very close object within a focus. So when an object is within a focus, that means the object must be placed between the pole and the principal focus of a lens. That means between the lens and the principal focus of the instrument, then you can use it to view a closer object. Now, another thing again, let us look at the diagram, a rough diagram of this instrument. This is a rough diagram of the instrument. Now, this is a principal focus. Let me extend it. Now, if this is a principal axis, rather. Now, we have at the point, we have the focus here. This is the optical center of the lens. Now, let's put an object within the focus. And what will happen? This is another focus here. What will happen now? We have something like this. So this is what I want to have. Then the object will be here. So now this is what a simple microscope. Now in this simple microscope, we check. This is the image. Let's call this one from here to this place. Let's call it D. I will tell you what D means. Let me indicate this one as the center direction. Now this is the object. Let's call this one, the eye will be here. We have the eye placed here. Now the problem students always have is that when they ask you a simple microscope, number one, you must know that it uses a convex lens. A simple microscope uses what a convex lens, not a concave. It uses a convex lens, and that convex lens is what acts as both the eyepiece lens and the objective lens. Why did I say so? Now don't forget that the eyepiece lens is used to see the image, to view the image. Why the objective lens is for the object itself. And when we are talking about a single lens used here, we still have other ones that we call compound microscope, although that is not treated here in this class. We'll look at that and in our next class. Now, it is used It uses only one convex lens to view an object that is within a focus, and we call them it produce a magnifying image. The image that is produced now is magnified. It is the image produced at this is and this setup is at normal adjustment. That means at normal adjustment. So the image produced now at normal adjustment, that means this setup is normal to see a distinct a close or a distinct vision, that is at 25 centimeter. Now in this case, now this place from here to here is the object. From here to here is the object. Now let's call this one alpha. Let's call that one alpha. And don't forget that this one, let's call it hi, the height of the object of the image. And let's call this one the h naught, which is the height of the object. Now, in this case, now u is your distance of object, while d is what? The least distance. Now, let us continue from where we stopped. We will still come back to this. He said what the image produced at normal adjustment is what? Is virtual, erect, and what? Magnify. Why? That is even the reason why we call a simple microscope a magnifying glass. Because what? They produce a what? A magnifying image. So what we have now is that the image that is formed by this what? A simple microscope is what? Is virtual, erect, and what? Magnified. When the object is placed within the focus. That means when the object is within the focus, is between the what? That means the object must be what? Less than the what? The object must be what? Less than the focal length. The object in question must be less than the what? The focal length. So the shortcut to remember this is what we call the VEM. VEM. So the VEM means what? Virtual, erect, and magnified. I repeat again, the virtual V, erect, and magnified. And the D there is the least distance of vision. D in this particular is what? The least what? Distance of what? Distinct what? Vision. The least distance of distinct vision, and it is equal to what? 25 what? Centimeter. So it is equal to what? 25 what? Centimeter. The least distance for distinct vision. For this particular eye to see at very clear vision, we said what? You must, what? The image must be set at a minimum of what? Or maximum of 25 what? Centimeter. That means centimeter. Now, another thing again we have to understand. I've also told us that what? That the lens that is used is a single lens, and that single lens acts as what? The eyepiece lens, and also what? It also acts as what? The objective what? Lens. That means it acts as eyepiece lens. It also acts as what? Objective lens. Another thing again we want us to understand here is that even while you are what? Using this microscope to observe an object, the object must be at a close distance. That is having a least distance of what? 25 what? Centimeter for distinct vision to be actualized. Now, I want you to also take note of this. Now, in microscope, the image I told you is erect and virtual. And for an image to be erect and virtual, it means that what? That the image is negative. Image will be what? The negative. That means image distance will be negative. Image distance and magnification will be what? Positive. Magnification is going to be positive. Don't forget, an erect image should produce a magnification of what? Positive sign. While inverted is what? Negative. Inverted is negative. Take note of that. Very important. And if we have what? Our image of the object to be erect, it means that the magnification is plus, and for it to be virtual, and for virtual image or erect image, we have it as what? Minus sign. Now, another thing again is that we need to learn is that we have also told you that the object must be placed what? Less than the focus. That means it must be placed between the lens and the principal focus. The object must be placed between the lens and the principal what? Focus. Now, if you want to look at it, 1 over f equal to 1 over u plus 1 over v. Now, that is a length formula. Length formula is 1 over u plus 1 over v is equal to 1 over f. Now, 1 over f, don't forget f will be positive because we are using a convex lens. A convex lens produces a what? A positive focal length, while a concave lens produces a what? A negative focal length. So as such, we are going to have what? 1 over u plus what? Then we are going to have minus 1 over d, which is now what? We are using a negative. That means our image distance is the least distance of distinct vision, which is d, capital letter d. So we are going to have it as what? 1. Now, what do? Let us multiply all through, knowing fully well that magnification is equal to what? Minus what? V over u, or image height over object height. That is magnification formula. So if you want to put it there, let's multiply everything by d. So d will now be what? D over, this one will now be d now in this case, because for this simple microscope, because if you put minus there, it will become plus. Don't forget, if I put minus d, minus will give us plus, so d over u. So in that case, we are going to have it as what? D over f. Multiply this equation by d. Multiply all through by d. What do you have now? D over what? Over u minus 1. So if you divide d divided by d is what? 1. Now d over u is what? Is the same thing as magnification. So d over f equal to magnification minus 1. So magnification is equal to what? D over f plus 1. So this is the magnification. Is the maximum what? Magnification of a simple what? Microscope. The maximum what? Magnification of a what? A simple what? Microscope. Now, don't forget that the closer the object to the lens, the bigger the what? The higher the what? Image. That means the image becomes more magnified as the object moves what? Closer. So take note of that. As my object moves closer, the image becomes what? More magnified. So you can increase the size of the object by what? By simply what? Increasing the what? Moving the object closer. That is what you can achieve in that. Now, I haven't done that. Now, what we need to do now is that what are the other things that we can talk about? Now, let's look at the object. How can we make object the subject of formula here? In this formula. So I would have 1 over f is equal to 1 over u minus what? 1 over d. If I make object the subject of formula, let me bring this one here. I would have 1 over f minus 1 over d equal to 1 over u. By bringing this one here, become plus. Okay? So that means that u is equal to what? What is the SCM first? Fd is the SCM. Fd divided by f, we have d plus what? This one divided by this, we are going to have f. So equal to what? 1 over u. Now, we go ahead to make u the subject of. So u will now be equal to what? Take inverse of this one to make your u. So fd over what? D plus what? F, which is what? 25 what? F over what? 25 plus what? F. This is our what? The formula for what? For object distance. Let's call this one equation 1, and let me call this one equation 2. Now, but there are cases where, before I will quickly look at the application of this particular simple microscope, let me also talk about a case where the eye relaxed. So if the eye itself relaxed, it means that the object position have changed. Now, if I place something like this, look at the board. I have a diagram like this. Now, I have a diagram like this now. Now, let me place the object at the principal focus, having the focal length of what from the lens to be what to be, or from the optical center to be f. Now, what will happen now is that we will notice that something will occur here, meaning that what the so in this case now, we have the what the image sent to what at infinity now. So that means this one now is what is a simple microscope when the object is at f. So now when the object, that means object is at f, the eye was relaxed. The eye relaxed when the object is at f. And what would that be the consequences of the what? Of the image that will be formed. Now, if the what? The eye relaxed and the object is what? That means the object distance is equal to what? The focal length. Therefore, magnification becomes what? G over U initially when we were talking about abnormal adjustment. So this one will now be what? 25 cm over f, because we now replace the U with f. So this is a formula for what? Magnification when the eye relax. Let me call it equation 3. At the point that is the object is at what? At the what? Principal focus. That means we place the object at principal focus to send the what? The image at infinity. So the image of this what? The image of the object is at what? At infinity. What does it mean to the eye what? To relax? It means that it is unaccommodated or unaccommodative at that point of what? Of relax. That means the eye what? Become calm. Is what? It's at that point it cannot accommodate what is coming what? To do it. That means it makes the ciliary muscles to what? To even relax alongside with it. So in that case now, we say such an image is unaccommodative by the what? By the eye itself. So we say it's unaccommodative. Accommodation means the ability to see, to visualize something. So that is just that. Now, having done that, I believe I've been able to explain some of the things we need to know about a simple microscope. We can also say, we can talk about the application that it is used for what? In a case of what? Soil particle, to see soil samples, to see fungi and algae in the soils. They can use what? A simple microscope to do that. They can also use them for pedology. Pedology is what? Using them to study samples. To sample. We can also use them for what? Dermatology. Dermatology is what? In the process of diagnosing the what? The skin condition. To diagnose is used for what? To study the what? The diagnosis of the skin. To diagnose, when you want to diagnose the skin condition, we can use them for it. We have so many things. We can use them to view closer distance. That means distance within the what? The focus. This can be done. And don't forget that I've also told you that what? A simple microscope is also known as the hand lens, or what we call the magnifying glass. And don't forget, when they are placed at normal adjustment, they are meant to see a vision that is an image that is virtual, erect, and magnified. And this image that is upright, that is erect, and that is magnified, and that is virtual, is what? Always produced by a simple microscope. We call it VEM, which is virtual, erect, and magnified. VEM is a shortcut for it. And don't forget that your object must be less than the focal length for you to visualize an image that is virtual, erect, and magnified. It must. the place within the focus must be less than the focus, and the vision that always be seen, the least distance of vision is what we call the what, the d equal to 25 what centimeter. Don't forget, this one is the minimum what magnification. Before I forget, is the minimum magnification of the lens that it can produce at this point. That means at this point now, the lens can produce what, a minimum magnification. Although at this point now of minimum magnification, the image is what, is at infinity, and the eye is what, unaccommodative. That means the eye relaxes at this point. My name is Engineer Halidi. I believe I've been able to explain some basic or rudiment about a simple microscope where I've talked about it. Don't forget, the principle upon which this thing operates is principle of refraction, because after the ray of light, don't forget, after the ray of light hits the what, the lens, it bends, it refract. The same principle here. After the ray of light hits the what, it refract, it bends afterward hitting the lens. So if they ask you in the exam what principle upon which one we use to what, to draw or to analyze a simple what microscope, you just tell them a what, a principle of refraction. Now don't forget, there are flux, there are limitations. Let me put it that way. There are limitations to this, which will now bring about what, a compound microscope that will be discussed in our next class. A simple microscope produce a very what, a low what magnification. A low magnification is produced what, for a simple what microscope. That is why we are going to introduce a compound microscope that is better than simple microscope. Please, if you are enjoying this class, please just help me click the notification button and subscribe. If you are returning viewers, please just subscribe to my channel so that we can always get to learn a lot of things from each other. Thank you very much. Now, a compound microscope is a better magnification than simple microscope. I want to also do something for me. Comment or give me one other ones, or one or two other things that is a limitation to what, a simple microscope. Type that and send it in the comment section. Thank you. God bless you.